In Module 4, Lessons 1 and 2, we're going to look at the relationships between addition and subtraction and also multiplication and division. So we'll start off with some tape diagrams. You're asked to draw a tape diagram to represent 5 plus 4. And so we can see in the tape diagram that there are 5 pieces in this first section and 4 pieces in the second section, for a total of 9 pieces. In part B, we'll write the expression. This is a numerical expression, 5 plus 4, for each tape diagram. So what we have in our first tape diagram is 2 plus 2. We don't put an equal sign because they've asked us to write an expression, and expressions do not have equal signs. Equations have equal signs. And then in the second example, we have 3 plus 4. Now in the exercises, we're exploring the concept. And so in question 1, they ask us to predict what will happen when a tape diagram has a large number of squares. Some squares are removed, but then the same amount of squares are added back on. And so if we remove a number of squares and then we return the same amount of squares back on, we should end with the same beginning number of squares. And now we'll prove that. We're going to build a tape diagram with 10 squares. Then we'll remove 6 of them and write the expression that shows that. So we have 10 squares, and if we then remove 6 of them, there are 6. The expression that we would write for that then would be 10 minus 6. And then if we were to add 6 squares onto the tape diagram, our expression would be 10 minus 6 plus 6. And if we add them back on, we would have these 4, and if we added 6 more onto that, we would have another 6. And that would mean that 10 minus 6 plus 6 equals 10, the number that we started with. Now, without having to draw the tape diagrams, we're going to use that same knowledge to fill in the blanks. It says using your knowledge of identities. An identity is when you can add or subtract 0 from a number and still retain the same number. So this is what we're looking at. If we start with 4, we add 5, and then subtract 5, we'll still have 4. So that's what we're asking for right here. If we added 5, we need to subtract 5. The next one, keep in mind that we have a starting number and that is our ending number. They match, so whatever we do in the middle has got to give us 0, essentially. So we have 25 minus some number plus 10. So if we have an adding 10 part here, we have to subtract the 10 if we want to still have 25 at the end. Now in C, they don't give us the starting number, but they do give us the ending number. And we can see that we're adding 16 and then subtracting 16, which is an even exchange. So our starting number has to be 45. And then in D, they give us the starting number and subtracting 20, adding 20. So our ending number needs to be the same thing that we started with, which is 56. Using that same information now, we're going to do the same thing with variables. If we start with A and we end with A, and then we're adding B, we would need to subtract B in order to still have A at the end. If we start with C, and then we subtract D and then add D back on, we'll have C when we're done. If we start with E, we want to add some number and then subtract F and still have E. So what we add has to be F. And then with D, we start with some number, we're going to subtract H and then add H back on, and we're going to end up with G. So our starting number has to be G. Then in lesson 2, we're looking at the relationship of multiplication and division. So we'll start off by using a tape diagram to represent division and also multiplication. So in our first representation, I had 8 pieces in our tape diagram. And it says 8 divided by 2. There are 2 different ways that we could represent that. The first one is to divide the 8 into 2 groups of 2, or into groups of 2. So this would be 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. And so we know that there are 4 groups of 2. Or we could divide the 8 into 2 groups, and each group has 4 in it. So either representation, either the top or the bottom representation, will show you the problem. And with multiplication, 3 times 2, again, I could do it 2 different ways. I only showed one. I have 3, and I made 2 groups of 3, which will be a total of 6. I'll just make one final observation on the problem set. Just like with addition and subtraction, multiplication and division erase each other. So if I start with 132 and I'm dividing 3 and then multiplying 3, you could assume that you're going to end with the same number. And of course you will.